Welcome to this explainer. Today we're diving into what I like to call the absolute nervous system of modern industry. I'm talking about electronics and instrumentation engineering, or EIE. If you've ever stopped to wonder who actually makes sure those massive automated factories don't just grind to a halt, or how medical devices achieve that literal life-saving precision, well, you're looking at the architects behind it all. This is a seriously lucrative, rapidly growing career path, and today we're going to lay out your exact blueprint for success in the field. Let's get into it.
Okay, let's dive right into our roadmap for today. We've got 5 key areas. First, EIE and Industry 4.0. Second, the EIE curriculum journey. Third, global careers and roles. Fourth, placements and salary comparisons. And finally, number 5, expert advice for success. So, starting us off with Section 1, EIE and Industry 4.0, the heart of automation. I want you to just think about this for a second. What actually makes a massive, incredibly complex factory run totally smoothly without human intervention? Or what ensures a robotic surgical arm moves with literally sub-millimeter precision? It's not just mechanical gears, right? And it's not just lines of software code. It's the invisible, highly intelligent technology that connects those two things together. And that brings us exactly to what this is. Electronics and instrumentation engineering is that vital bridge. It's the bridge between the hardware, the software, and the automation. It's the discipline that blends electronics, instrumentation, and control systems to basically guarantee that industrial processes are incredibly efficient, dead-on accurate, and, above all else, safe. By choosing EIE, you aren't just learning one single isolated skill. No, you are mastering the entire ecosystem of modern tech. And honestly, that makes it an exceptionally future-proof choice.
You see, while traditional engineering paths can sometimes leave you kind of siloed into strictly mechanical or strictly software domains, EIE is completely dynamic. It demands this really rich interdisciplinary skill set. We're talking about integrating the Internet of Things, robotics, programmable logic controllers, and SCADA systems. You become the person who actually understands the whole picture. And let me tell you, that is exactly what smart factories and Industry 4.0 are demanding right now.
Moving right along to Section 2, the EIE curriculum journey, building your expertise year by year. So what does this actually look like in college? Well, your skills are going to systematically stack up over time. Now, your first year is generally your common engineering basics. We all know that. But by year 2, you are diving deep into core foundations. Think digital design, microprocessors, and electrical machines. Then year 3 ramps things up into advanced applications. This is the fun stuff, where you tackle analog and digital VLSI design, power electronics, and transducers. And finally, year 4 is all about specialization and practice. You'll take on advanced process control, maybe medical instrumentation, and most importantly, you'll apply every single thing you've learned in a thesis or a heavy-duty industrial internship. It's just a beautiful, logical progression from basic circuits to massive, real-world systems. Now, the really crucial takeaway here is that this curriculum equips you with the exact tools the market is practically begging for. Subjects like distributed control systems, embedded systems and IoT, VLSI design, and even AI and machine learning, these aren't just academic hurdles you have to jump over. They are the absolute high-demand competencies that make EIE graduates incredibly employable. Literally, when a company decides they want to modernize and become a smart facility, these are the exact skills they are hiring for sure. Which leads us perfectly into Section 3, Global Careers and Roles. Where can EII take you? Mastering that curriculum unlocks some truly phenomenal career doors. The diverse applications of an EIE degree are honestly staggering. In manufacturing and process control, you could be the lead engineer managing a fully automated petrochemical plant. Or if you lean more towards healthcare, you might be designing the next generation of precision biomedical devices. And hey, let's not forget the government and defense sectors. EIE engineers are heavily recruited by really prestigious public sector undertakings, or PSUs, places like Indian Oil, Hindustan Aeronautics Limited, and the DRDO. Plus, this degree travels incredibly well. The demand for automation experts isn't just localized to one area. There are massive, really exciting overseas opportunities waiting in the USA, Canada, and the UAE. Major tech giants like Samsung and Nokia, along with huge robotics and aerospace corporations internationally, they are constantly headhunting talent with an EIE background. All right, time for the numbers. Section 4, Placements and Salary Comparisons, the data behind the demand. We aren't just looking at vague statistics here. We're talking about your literal earning potential. Let's look at some fresh data from the National Institute of Technology Waringall's 2024-2025 placement season. It shows exactly what top-tier placement looks like right now. For the MTech Electronic Instrumentation and Embedded Systems branch, graduates saw a median CTC of 24 lakhs per annum, reaching a maximum of 43 lakhs. I mean, wow. That is a massive return on investment for mastering these highly specific instrumentation and embedded skills. Now, let's compare that against the broader engineering landscape, because this is fascinating. Everyone just naturally assumes computer science is the undisputed king of compensation, right? But based on that exact same campus data, computer science BTech boasts an average of 22.63 LPA and a median of 20 LPA. Meanwhile, the electronic instrumentation and embedded specialization sits at a 22.59 average and actually beats CS with a 24 LPA median. No way, right? It confidently goes toe-to-toe with computer science in terms of pure earning power, all while vastly outperforming traditional branches like mechanical engineering. And that earning power, it scales beautifully over your career. On average, across the industry, freshers are going to start somewhere around 3.5 to 6 lakhs per annum. But as you gain experience and you start to specialize in things like automation or DCS, your mid-level salary easily doubles to around 10 or 12 LPA. And once you hit a lead or senior position, say you become a lead instrument controller with a decade of experience, you are looking at packages scaling all the way from 21 up to 28 lakhs per annum. It really proves that in this field, your expertise directly dictates your value.
So how do you make sure you actually hit those top-tier numbers? Let's turn to Section 5, Expert Advice for Success, Wisdom from the Community.
I absolutely love this piece of advice from a veteran in an online engineering community. They said, if you want to be an expert, you'll need practical experience. Can you get a job on the maintenance side? And they hit the nail right on the head. Theoretical knowledge is fantastic, but getting your hands dirty, maybe working in maintenance for an electric car manufacturer or a robotics facility, that is what truly solidifies your understanding. Real-world practical problem solving is what's going to make you an indispensable engineer.
And consider this insight from engineering educator Ujwal Kumar Sen. He says, control systems can change your life. It is used in a mall, in an industry, in war, and nowadays in homes. It is so important to remember that the math and the circuits you're studying late at night, they have massive, literal, life-changing applications in the real world. You are literally going to be designing the systems that dictate how the modern world functions on a daily basis.
Which brings us to our final thought. You've seen the curriculum, you understand the immense global demand, and you've seen the hard data proving the exceptional earning potential of this career path. The future of Industry 4.0 is automated, it's intelligent, and it is highly precise. So the only question left to ask is, are you ready to become the nervous system of modern industry and build your future in electronics and instrumentation engineering? Think about it. Thanks so much for joining me on this explainer, and keep learning.